Hello there, my name is Florian and I welcome you to IT Tech Tips. Today I want to talk about a topic which is really important for the running of a business. I'm talking about backup. And I don't just mean copying some files on a USB stick or an external USB hard drive. I'm talking about the whole backup concepts and what types of backups there are and what you should consider when interviewing your customer to define the correct and suiting backup concept. If you don't want to miss any other topics, please consider subscribing to this channel and ring the bell. And now let's have a look. Why should you even bother taking backups? For once, it enables you or your customer to return to older versions of a file. If you accidentally changed something in a file and pressed the save button, you want to be able to go back to an older version of the file. Of course, you could do that with volume snapshots and other methods as well, but backup is one method of doing it. It enables you, of course, to restore deleted files, which for many people is the most prominent reason to take backups. And it enables you as an IT administrator or operator to restore, for example, servers without the runtime performance impact a real snapshot from the hypervisor would have. So instead of taking snapshots with a hypervisor, which is a really quick way of doing it, but has some cost implications in the runtime performance, you could take a full backup, then do your changes, and if they didn't work, you can revert back to it using the full backup you have just performed. It also enables you, it's about the same, to restore whole systems, for example, complex client configurations or complete servers after a critical failure, for example, if your storage failed. Also, a really important point, especially nowadays, since like 5, 6, 7 years, there's this prominent threat of ransomware where many companies get attacked, their files get encrypted, and they have to pay a ransom to get their files back. So, first of all, if you got attacked with the ransomware, don't pay the ransom. That's really important because if you do, this enables these criminals to have a business model which is sustainable because they would know if I attack someone, they pay me money and they will continue doing it. So if you get attacked, don't pay the ransom. If you have a good backup, ransomware is not such a big deal. You can just restore back the files that got encrypted. A good backup concept also enables you to recover from natural disasters like earthquake, water, fire. If your whole server park is underwater or on fire, you want to have an offsite backup from which you can restore the files back from another location. And for me as an IT manager, having a good backup concept at my customer's side just enables me to better sleep at night. It's that simple. So when you talk to your customer about backups, you should always ask him, how expensive is it for you to lose critical data, even for a short period of time like 1 week? And this cost, which includes downtime in production, not being able for the customer to provide its services, or the reputational impact because it's really embarrassing for a company to lose data due to a bad IT concept. And this cost is the maximum amount a backup should cost. So it's an easy way to determine how large the budget for a backup concept should be. And always remember, no backup, no mercy. If someone does not care about taking backups and loses data, it's their fault. There are different types of backups you can take. For example, there's the full backup, which takes a full backup every day, for example. Then there's the differential backups, in which The delta, the difference to the last backup, is taken at every step. And there's the incremental backup, which just backups the differential to the last backup. Each backup is part of a backup chain. So, first backup, the second backup, the third backup, and so on. Let's have a closer look at the full backup. At the bottom we have the timeline, and the first backup has some data to back up, of course, and some changes which are done during the period between the last backup and the next backup. So the second backup will back up the whole backup set containing the initial data plus the changes. In this diagram, changes 1. Then during the period between the backups, some data may get deleted, and this data will then not be part of the third backup. And after that, it continues like that. Every day or at every step, depending on how you configure the backup, a full backup is taken. A full backup is a very safe way to perform backups because there are no broken links in the backup chain ever. Every backup is a standalone backup because the whole data is backupped every day. So a full restore of a complete system, data, operating system, etc. is a little quicker than with other methods. But there's a huge amount of storage needed because every day at every backup step there's a complete backup of all your data taken. So that's also why each backup takes very long to take. With differential backups, we also have the timeline at the bottom. There's also some initial data to back up. And then we have the changes. And we will only back up the changes on the second backup. And then some more changes. In this diagram, changes 2 are done, and these changes will have to be backupped as well in the third backup, which then includes changes 1 and changes 2. The next changes, changes 3, will be included in the fourth backup as well. So a differential backup is still rather safe. You can still restore some of the data if your backup chain is broken. At least you can restore the data before the broken link and some of the data after the broken link. The backups are still rather small for shorter chains. For example, if your chain consists of a full backup every week and a differential backup in between, the backup files are still rather small, except your customer has a huge amount of changes in his data between each backup. Then they also get large, but that would be the case with every type of backup. The backups are still pretty fast for short chains, but they are rather slow to restore, at least slower than restoring data from a full backup. And the longer the chain gets, the slower the backup gets, because there will need to be a calculation for the difference between the current backup and the first full backup, or better, the last full backup in the backup chain. Also, there's a large amount of storage needed for longer chains. Usually not as much storage as with a full backup every time, but still much more storage for longer chains than would be needed with an incremental backup, which we'll have a look at in the next slide. Incremental backups. On day 1, we also have our initial data to back up. Then we do have some changes, as with the other backup types, and on day 2 we will only back up changes 1, the changes from the last day. Then we have some changes in this time period, and on the third backup we will only back up the changes between this backup and the last backup, and so on. So the fourth backup would contain only changes 3. As you can see, the backup is considerably smaller, and the longer the chain gets, the smaller it is compared to a differential or even a full backup. As I said, it's the smallest amount of storage needed for incremental backup, even for longer chains. The backup is pretty fast, also for long chains, because we only back up the difference between this backup and the last backup. Remember the difference to the differential backup? With the differential backup, we back up the difference between this backup and the last full backup. So with the differential backup, we have more changes to back up the longer the chain gets, and with the incremental backup, we always only have the changes between this backup and the last backup. The restore tends to be really slow with incremental backups, because depending on what file or what system you want to restore, the backup software has to iterate through the whole backup chain to find the data which is to be restored. It's also the least safe method. If one link in the backup chain breaks, usually the whole backup set is broken. So that's why modern backup software has some additional methods to deal with that, for example with indexing files from the whole set in each incremental backup or stuff like that. So it's not as insecure as it used to be 10-20 years ago, but still incremental backup is, compared to differential or full backup, the least safe way to take backups. So there's always a trade-off between storage needed, safety of the backup, and amount of time needed for the backup, and amount of storage needed for the backup. These are all things you have to consider when defining a backup. Which brings us to our next topic, defining a backup. So how should you define your backup, also known as the backup concept? First of all, you have to think about the backup interval. That means how often should you take the backup. So faster intervals mean that the backups are taken more often, for example hourly, which probably would make sense for a heavy database related system. But faster backup intervals usually slow down the system, because each backup takes up some system resources, because taking a backup needs some CPU, some network bandwidth and some storage. And depending on how your system is configured, whether you have a dedicated backup network, dedicated backup servers, agents, etc., or you're in a smaller environment where everything runs on one system, the performance impact would be considerable or just a little bit. That's what you have to decide as an IT professional for your customer. Faster intervals usually take up more space, but they are more accurate for restoring data. Slower intervals mean the backup is taken less often, for example every night, and this will interfere only little with the system, and it uses of course also less space, but it's also less accurate for restoring data. For example, if a file gets deleted at 4 o'clock in the afternoon, or a database is corrupt at 4 o'clock in the afternoon, and you want to go back to midday, this will not be possible if you only take backups at night. So you would only have the possibility to go back to the file, to the status of the files from last night. There is sometimes a bit of confusion between retention time and restore points. So let's have a quick look at the difference between these two. Retention time on the left side and restore points on the right side. Retention time means how long, and in a sense of duration, like time, for example days, hours, how long should a backup be kept. And with the restore points, you define how many backups to keep. So if you have a retention time of 1 day and you have like 7 days of retention time, then you will keep 7 backups. If you define you want 7 restore points kept in the backup chain, and you define that the backup is run daily, you will also have 1 week of backups in your chain. But it's another way of calculating how much backups you want to keep. A longer retention time means you can go back further. And more restore points also mean you can go back further. Shorter retention times, of course, save storage space. The same goes for less restore points, they also save storage space. Thinking in terms of retention time is a good way of planning backup generations. We get to that in the next slides. And thinking in terms of restore points is a good way of thinking about backups to account for storage limitations. So depending on where your priorities are, you should think in terms of retention time or restore points. I usually think in terms of retention times because it's much easier to explain to a customer. So what should you back up after all? This really depends on the needs of your customer. It may make sense to back up complete systems. This is then called a bare metal backup. But there's a huge amount of storage needed for bare metal backups because all data in the system is backup, including temporary files, system states, redundant files, etc. But it does enable you to recover complete systems, including operating systems, rather quickly. So this might be a way to back up important server systems or systems which have to be restored really quickly after they crash. It's also really easy to define a bare metal backup. You just tell the backup software to back up everything and you don't really have to think about it anymore. Then there's the file backup, which means that you back up only the files that you really need. This must be discussed with the customer. I usually do that in written form, so the customer knows exactly what we back up and what he will be able to restore. And that's also a way to avoid legal conflicts. It does save some storage space because you don't just back up everything, but only what you really need. And it enables you to quickly recover your files, but just your files, not whole systems. This unfortunately does not work with most databases because they have transaction logs and you cannot just back up database files or even certain application files and just restore them and the application or the database continues working. So you would need to have a more intelligent backup to do that. And that brings us to the application-aware backup. Application-aware backup is implemented in most modern backup software for popular applications. For example, the MS SQL server or the MS Exchange server. But what does application-aware backup mean? That means that the backup software has some intelligence. It knows how the application works, and through that knowledge the backup software is able to perform a correct backup of the application and with the restore bring the application back to a state where it will continue running. For example, with an application-aware MS SQL backup, it will freeze the database, it will truncate the transaction logs, and then it will back up the files, so the database is in a predefined state when you restore the files and will continue working after the restore. Now let's have a look at backup generations, which is also an important topic. Backup generations, or the grandfather-father-son concept. You might have heard of it already. If not, this slide is going to be really important for you. GFS stands for grandfather-father-son, also known as backup generations. The concept behind it is to enable you to go back really far when restoring files while still not using too much storage space. So how does this work? For example, you create 3 backup jobs for the same data. More advanced backup software can do this with just a single backup job, but for understanding the concept, let's say we create 3 backup jobs. The job 1 is the son job, which is a daily backup with 1 week of retention times. That means 7 restore points, as we've seen in one of the previous slides. The second job would be the father job, which is a weekly backup with 1 month of retention time. So you can go back 1 month, not just 1 week, which would result in 4 restore points. And the third job, the grandfather job, would be a monthly backup with half a year of retention time, which results in just 6 restore points but enables you to go back half a year for restoring your data. And the idea behind it is that it's really unlikely you need a day exact precision if you need to restore a file from like 172 days ago. Usually it's just, give me back that file, I deleted it like some month ago, and just give me the latest version of it. And it then usually doesn't really matter whether it's a file from exactly one specific day, it's just the file around March, for example. But if you want to restore a file which was deleted 2 days ago, the customer usually wants to tell you precisely which file he meant. For example, he wants the file from Wednesday. So for the first generation backup, the Sun backup, we then take the file from this 1 week retention time, which is taken daily. And for the file which we want to restore from 172 days ago, we take the grandfather backup job, which only takes 1 backup per month, but keeps them for half a year. So basically, it's likely that you need a precise restore for a file you just deleted recently, like yesterday, and the precision for files you deleted a long time ago does not need to be that high. Then we have another rule you really have to know about. It's the 3-2-1 rule. That means you have 3 copies of the same data, whereas the first copy is the original. You have 2 backups on separate media. For example, one directly attached storage and a NAS or a SAN. And you have 1 backup offsite. So you are protected from natural disasters. So 3, 2, 1. That's a really simple rule to remember and very important when designing backups. Because if you stick to the 3-2-1 rule, you can be pretty sure that you are able to restore the backup because you have 2 backups and one of which is not prone to natural disasters. There are some more things to consider when defining backups. For example, the recovery time objective. So what does this mean? That means how much time, the duration, can the restore of a backup take at the most. So you have to discuss this with your customer. If this is a critical system, usually even 1 hour of downtime is unacceptable. So you have to scale your backup, the performance of your backup storage, the method of your backup, the performance of your backup agents to suit the expectations. Usually if you have really short recovery time objectives, backup systems tend to get really expensive. So discuss that with your customer and scale the backup according to the needs of your customer. Then we have the recovery point objective. And that means how far back must you be able to restore files? Is it just days or weeks or months? How many versions of a file you want to keep in a backup? You also have to discuss that with your customer. If your customer wants a daily full backup, which goes back for 5 years, he will probably have to invest a lot of money in storage. So try to find a good compromise between costs and safety. There are also different levels of backup. We have the inconsistent backup, which is not used anymore. That's when you, for example, just select all files you want to back up, press Ctrl+C, go to a USB hard drive, press Ctrl V to paste the files, then the backup will just start taking files, and while copying the files, which might take several hours, the files can change. And the backup on the target will be inconsistent because the files which are backed, including the changes which happened in between, may relate to another, and that's why they are inconsistent, or they may be inconsistent on the target. So I already said too much about it. Every modern backup software does not do that anymore. Then we have the crash consistent backup, which is the typical way to back up data, which takes a snapshot of the file system. Most operating systems support that nowadays. So before it copies the files, it takes a snapshot, which is like a photograph of the file system. So the backup software can be sure that the files which land on the target are the same files which were on the source system at the beginning of the backup. So every change in between while the backup takes place is ignored. And then the best way to do a backup is the application consistent backups. This only works with intelligent backup software which knows the inner workings of the application it does backup. So that's application aware or application consistent. I talked about that like 5 minutes ago. Also an important point to remember, a backup is not an archive. This is also important for legal reasons because some businesses need to archive their files, but there are other requirements which an archive must fulfill than what a backup software must fulfill. For example, an archive requires that the files in the archive have a certain type of file, which is probably readable even in 20 years. For example, images must be JPEG in a certain format, or documents must be PDF-A, which is the PDF archive format, in a certain version, or fonts must be embedded, or you need to have metadata information in a zip file. This is an archive. A backup is really just meant to back up files or systems and restoring them as quickly as possible. And one thing which gets forgotten pretty often is test your backup regularly. For example, restore some files every few months and report that back to your customer. This may also be important for legal reasons. So in summary, create a backup concept before configuring the backup jobs. Consider recovery point objectives, recovery time objectives, and talk to your customer and write down the backup concept and let your customer sign the document. Be aware of what data to back up. Also, you have to discuss that with your customer. Is it just files? Is it also operating systems? Does the backup contain data from cloud services like email or cloud storage? If at all possible, of course it needs a little bit more budget, but if at all possible, stick to the 3-2-1 rule. It's a really important rule. Discuss the concept with your customer, as I said before, and beware of the limitations of a backup. A backup is not a free ticket to do whatever you want with your system, because usually you don't back up a complete system and it will take time to restore if something breaks. So a backup is kind of like a last resort if something bad happens. You should not, as a business, depend on the backup 100%. The business might be partially or completely down during a restore, and this can cost a lot of money to the business. So that concludes our lesson for today. I hope you liked it. If you did, please consider subscribing to this channel and ringing the bell. Thanks for watching. See you next time.